We have been learning about monomials, and we've been talking about some different exponent rules that let us calculate with monomials. What you are going to get an introduction to today is something called a polynomial. So the idea of this lesson is to introduce you to what a polynomial is. So you should be able to look at something and tell me, yes, it's a polynomial, or no, it's not a polynomial. And you should also be able to do something called identify the degree of a polynomial, which is a way we classify polynomials, and also talk to me about some basic polynomial vocabulary by the end of the lesson, which is why this lesson we're calling your polynomial introduction. It's going to teach you all of the basic things you need to know about a polynomial, because the second half of the chapter, which we're going to be moving into soon, you are going to be working with polynomials. So a little bit about what a polynomial is as part of our intro. So if you think about stems and meanings of words, poly, which is part of the word polynomial, means many. So a polynomial, it can be a monomial, which we've talked about. It can also be several monomials, because poly means many, so many nomials, many monomials. So a polynomial is an algebra expression that can be a monomial, or it can be the sum of monomials. So it can be made up of a bunch of monomials added together. Sum of monomials. So you can call, so if you have a bunch of monomials, you're adding them all together, you can call it a polynomial. Sometimes we name polynomials based off of how many monomials we're adding. So each monomial we're adding in a polynomial is called a term. And we'll look at some examples of this in just a second to help you make sure you're understanding it. So if I'm adding a polynomial with two monomials or two terms, then rather than calling that a polynomial, a lot of times people will call that a binomial, because bi means two. And the same thing, so if we have a polynomial with three different monomials that we're adding, or three terms, rather than saying polynomial, a lot of times people will call that a trinomial, because tri means three. So we're going to help you wrap your head around polynomial, binomial, trinomial terms. Is it a polynomial? We're going to look at some problems, and we're going to classify them together to see if they're polynomials and what type. So remember, a polynomial is made up of monomials. So in order for something to be a polynomial, all of the pieces have to be monomials. If you need a reminder of the rules for what a monomial is, you can go back to your notes that we took about monomials at the beginning of the chapter, and you should have a checklist of things that need to happen with an expression for it to be a monomial. So you'll have to forgive the formatting on this. It went a little bit funny when I made the video, but these are the same example problems that are on your notes outlined for today. So we're going to go through each of them. So this first one is just an x. So that meets all of the criteria for a monomial. So we can say that, yes, that is a polynomial, and the type of polynomial it is, if we wanted to give it a name, is a monomial. Now we're going to look at the next one. So notice that we are adding. So we have to look at each part, the 5rx and the 7tuv, and decide, are those both monomials? Both of those meet the criteria for a monomial, pardon me. So that means that this is a monomial and this is a monomial. Both of those pass the monomial test. So that means that this is a polynomial, because all of the pieces are monomials. So yes, it's a polynomial. So each of these monomials, here's one, here's another one. Each of those are two terms. So we would say that these have two terms because there's two monomials in it. And we just said that a polygon with two terms is called a binomial. So if we wanted to classify this, it would be a binomial. Now, we're going to look at the next one. So in order for this to be a polynomial, each of the pieces has to be a monomial. And you can look in here and you can see that we have some problems with this guy. So we have a couple of problems. One problem is right here, we cannot have a variable exponent. That breaks the rules for a monomial when we talked about monomials. So that means that that is not a monomial. Which means that this is not a polynomial because that's not a monomial. So we have to have monomials in order to have a polynomial. Not a monomial, which means also not a polynomial. So we wouldn't classify this because it's not actually even a polynomial. So the last one is this guy, and yours it's off on the right side. My formatting is a little bit different than yours. So here we have 3 different pieces, so we have to check each piece or each term and see if it is a monomial. So that passes the monomial test, that passes the monomial test, and that passes the monomial test. Since all of those are monomials, we can say, yes, this is a polynomial. And since it has 3 terms, polynomial with 3 terms is a trinomial. So hopefully that gives you the idea of what a polynomial is and the different ways we can name it. So the way we check to see if something's a polynomial is to make sure that each of the individual pieces are monomials. One side note on this, by definition, a polynomial is a monomial or the sum of monomials. So if you look in this guy, you'll see, well, we're subtracting, but you have to remember that subtraction can be turned into addition. So negative 3y squared minus 2y, you could rewrite as negative 3y squared plus negative 2y. We can change subtraction to adding. So wherever it's talking about adding, subtraction kind of gets lumped into that since we can convert any subtraction problem into an adding problem, just in case you're wondering about that. So that's how we tell if something's a polynomial. Once we decide that something is a polynomial, so these guys that we said yes to, there's some information that we can use to talk about or to classify polynomials. One way that we can classify polynomials is using something called the degree of the polynomial. So we're actually going to start by talking about the degree of a monomial because monomials are polynomials too. So the way we find the degree of a monomial is we look at the exponents on all of the variables in the monomial and we add them together. And that number we get is called the degree of the monomial. So a couple of examples to help you see it to make sure you get it. So if we're looking for the degree of monomial, we just look at the variables. So this guy, the only variable, the first one, is just this x. And we know that x is the same as x to the power of 1. So we would look at the exponent, and that exponent is the degree. So the degree of this monomial is 1. Now this other monomial, 7 times x times y to the power of 5 times z, that has a bunch of variables in there. So we have to look at the exponents of all of the variables. And remember, if a variable doesn't have an exponent, it's because the exponent is 1. So x is really x to the power of 1, and z is really z to the power of 1. So I would take those exponents off of all the variables, since I have more than 1, and I would add them together. So 1 plus 5 plus 1 equals 7. So that means the degree of that monomial is 7. So that's how you find the degree of a monomial. We can also find the degree of a polynomial because a polynomial is just made up of a bunch of monomials. So the way we do that for a polynomial is we find the degree of each monomial in the polynomial, and whichever one is the biggest or has the highest degree, that's what we use for the entire polynomial. So to find the degree of a polynomial, find the degree of each monomial, then use the monomial with the highest degree, and that represents everything. So this is an example. We've got a big long polynomial here, and it has 4 different terms or 4 different monomials. So we would go through and we would find the degree of each of them. So if we go through r to the power of 1 and t to the power of 1, if we add those together, that first one has a degree of 2. R to the power of 1 and t to the power of 2, 1 plus 2 is 3, so that has a degree of 3. R to the power of 2 and t to the power of 2, 2 plus 2 is 4. And in case you are wondering if it is missing a variable, you think, well, we need the variables to add up the exponents to find the degree. So what's the degree of something that doesn't have any exponents? We would say that it is a degree of 0. Because if you really wanted to, you could add something like this in, because we know that equals 1. 13 times 1 is still 13. So not having a variable there is kind of like having an exponent of 0. So we would say that if it doesn't have any variables, it has a degree of 0. So since this is a polynomial, in order to get the degree of the polynomial, we need to go through and look and see which one of these is biggest. So we have a 2, a 3, a 4, and a 0. 4 is the biggest, so that means that we are going to use 4 to represent the entire polynomial. So that means that this polynomial, we would say, has a degree of 4. So one last thing about polynomials for today. So now we've talked about what a polynomial is. We've talked about how to find the degree of a polynomial, which gives us a way of talking more about polynomials. We're also going to talk about some rules. The last thing, writing polynomials. So there are some rules for writing and working with polynomials in math, because a polynomial has multiple terms or multiple monomials making it up. There are some rules for what order things are supposed to be written out in a polynomial. So when you're writing out a polynomial, they're written out, the monomials, in order from the highest degree to the lowest degree. And when you write it out that way, we call that standard form of a polynomial. So we're going to come back to this last part in just a minute, but I want to look down at this polynomial at the bottom of the page so that we can talk about putting it in standard form so you can see what it looks like. So we have 4 terms down here, so if we wanted to put this in standard form, we need to figure out which of the pieces has the highest degree. So this has a degree of 0, degree of 2, a degree of 4, and a degree of 1. So we want to write them out in order from highest to lowest. So highest would be the 4 times x to the power of 4, and then minus 2 times x to the power of 2, because that has a degree of 2, minus 3x, which has a degree of 1, and then that 8 is a positive or a plus 8, plus 8, because that has a degree of 0. So, pardon me, I wrote an exponent incorrectly. That first exponent should be a 4. So that's what the polynomial looks like written in standard form. One other thing that you hear a lot of talk about, and we're actually going to come into play with some things that we're going to learn in the next chapter or two, is something called the leading coefficient. So if you take a polynomial and you put it in standard form, that very first term, whatever its coefficient is, so remember the coefficient is the number that tells you how many of that thing you have. So this guy, the coefficient would be 4. So whatever that coefficient of that first term is, that's called the leading coefficient, which makes sense because it's on the leading or the front term. So leading coefficients are used to work with some different calculations that we're going to learn how to do as we talk about some different things working with polynomials, which is why it's good to know that vocabulary. So this polynomial, its leading coefficient would be 4, because when you put it in standard form, that first coefficient, that first number is a 4. So at this point, you should be able to take an expression and you should be able to tell me if it is a polynomial or not. You should be able to tell me the degree of the polynomial, and you should be able to write the polynomial in standard form. You are now going to work on your assignment for the day, which is going to let you practice each of these things.